Right, so now that we know that the orbit is an ellipse and we defined the radius vector in terms of the eccentric anomaly, let's define it in terms of the true anomaly. So if you recall, the eccentric anomaly was the angle connecting the aphelion to the center of the orbit to a point in the circumscribed circle in a vertical from the planet to the line of apsides. Now let's do that in terms of the true anomaly. The true anomaly is the angle connecting the sun to the planet through the line of apsides. That's this angle here, C, S, and P. Now I flipped the orbit here so that these angles are in the first quadrant. So it's easy to see the geometrical relations that we're going to work out. So let's write here. First, in terms of the eccentric anomaly, the position x is equal to the semi-major axis times the cosine of the eccentric anomaly, because the semi-major axis is the segment BQ. Now let's write x in terms of the true anomaly. You have the sum of the two distances, s to the point h and b to the point s, here where the sun is. So the first one, b to the point s, is equal to a times the eccentricity, and the segment sh is equal to r times cosine of f, where r is the radius vector sp. So you can relate these quantities to find the relationship between the eccentric anomaly and the true anomaly. So we have here a relationship that depends on r over a, and that, to solve that, we make use of the relationship that we already found for the radius vector in terms of the eccentric anomaly, which was r is equal to a times 1 minus e cosine of big E. So plugging this radius vector into the equation for cosine E, and now solve for cosine E. So this is the relationship between the eccentric anomaly and the true anomaly. So using this relationship, you can plug this cosine E again on the radius vector equation to find the relationship between the radius vector and the true anomaly. It's simply substituting the cosine of big E, put it all under the same denominator, and expand the eccentricity multiplying the second term. So the linear term in eccentricity in the numerator cancels, and you find the relation. R is equal to a that multiplies 1 minus z squared over 1 plus e cosine f. And these relationships are useful in dealing with orbits. The radius vector in terms of the eccentric anomaly, the true anomaly in terms of the eccentric anomaly, and the radius vector and the true anomaly.